Before we start, what's dimensional analysis? All that is making sure that units are compatible. We can't be adding area to volume or volume to length. We have to add length to length, area to area, and so on. So we're making sure we're not combining the wrong types of units. So looking at this here, we've got a cuboid with side A, B, and C, and we've been shown the front face. We're asked to find the perimeter of that front face, given that A is 3, B is 5, and C is 7. Well, the perimeter is just the distance around the outside. So in this case, it is A plus B plus another A plus another B. So we have got 3 plus 5 plus 3 plus 5. We could write that differently as saying, well, we've got 2 lots of 3 plus 2 lots of 5. The answers are the same. The answers are still both equal to 16. But 16 what? That's the key. What have we actually got? So what units is this? Well, we can see that they're all centimetres. So in this case, we have got 2 sides. Well, that's just a quantity, so that has no dimension. And we've got 3 centimetres. We have got 2 sides, again, that's a quantity, not a dimension. And we've got another side of 5 centimetres. So we're adding centimetres to centimetres, which gives us a unit of centimetres. So the perimeter is equal to 16 centimetres. So that we know is just length. Don't forget, anything to the power of 1 we don't show. So that's centimetres to the power of 1. We don't tend to show that. Centimetres length is said to have 1 dimension. Okay, let's move on. So in this question, we're asked to find the area of the front face. So we are looking at the area of this. Well, the area of a rectangle is, in this case, A multiplied by B. So therefore, the area is A, which is 3, multiplied by B, which is 5. Well, 3 times 5, that's easy. That's just 15. But 15 what? What are the units? So let's look at this. Well, the 3 represents centimetres. That's a length. Don't forget, that's to the power of 1. The 5 also represents centimetres. That's also to the power of 1. And if you remember your index laws, when you're multiplying with the same base number, in this case centimetres, you add the indices. So I end up with centimetres squared. Well, centimetres squared is area. So my answer, my area is, which is exactly what I want, 15 centimetres squared. And that is 2-dimensional. And that is 2-dimensional. Again, let's move this forward. Now we're looking at the volume of this cuboid. So the volume is, in this case, A multiplied by B multiplied by C. So you find the area of the front face and you multiply it by the length. So we have got A multiplied by B, well that's 3 multiplied by 5, multiplied by C, which is 7. So 3 times 5 is 15, and 15 times 7 is 105. But again, 105 what? Let's look at the units. The 3 is centimetres to the power of 1. The 5 is centimetres to the power of 1. The 7 is centimetres to the power of 1. Back to our index laws. Same base number, add the indices. That is centimetres cubed. So our answer is the volume equals 105 centimetres cubed. And that obviously, as we know, is volume, and that is 3-dimensional. Right, let's take this one step further. In this case, we are told that the radius and the height are both in centimetres, and we are looking to find out if these questions here are lengths, areas, volumes, or none of those. So to do this, we identify the units of these questions. Well, pi doesn't have any units, so we're not going to use that. Radius is centimetres, and in this case it's squared, so this is actually an area. In this case, 4/3 doesn't have a dimension, pi doesn't have a dimension. We have got the radius, which is centimetres. For this one, it is cubed. Well, centimetres cubed, we know, is a volume. Question 3, pi doesn't have a dimension. The radius is centimetres, it is squared. And we're multiplying that by the height, which is also centimetres. That's centimetres to the power of 1. Again, when you multiply with the same base numbers, you can add the index numbers. So we have here centimetres cubed, and that is a volume. Quite a simple process, really. Let's look at 3 more. We have 2 terms. So the first term, 3, no dimension. Pi, no dimension. Centimetres squared. Add 2, no dimension. Pi, no dimension. R squared, that is centimetres squared. So in this case, we can collect these terms. So we end up with centimetres squared, and that is an area. 2 more terms here. 2, no dimension. Pi, no dimension. R squared, well, that is centimetres squared. And we're adding 2, no dimension. Pi, no dimension. R is centimetres. and it's multiplied by h, which also is centimetres. They are both to the power of 1, so they become centimetres squared. So now we've got centimetres squared plus centimetres squared, and that is centimetres squared. Because they're the same term, you can collect them. We have got area. Final question. Pi, no dimension, r squared, well that is just centimetres squared. We're going to add 2, no dimension, pi, no dimension, r is just centimetres. That's to the power of 1. So the problem here is you can't do anything with this because that there is an area and that one is a length. So this is a question that you can't give an answer for because you can't add an area to a length. I hope that helped. Hopefully you got something out of this. If you did, please like and subscribe. As always, well done.